Imagine this, the blue planet we call home, with its oceans, forests, and mountains, was once nothing more than a ball of boiling fire. No life, no air, no oceans. Just chaos. Billions of tons of molten rock spinning in the darkness of space. Hard to believe, isn't it? Yet every tree, every drop of water, and even you and I were once part of that fiery chaos. Welcome to World's Echoes, where we explore the unbelievable truths about our universe and the mysteries that shaped our existence. Don't forget to subscribe so you never miss stories that make you see the world in a whole new way. Let's go back 4.5 billion years, to a time when there was no Earth, no sun as we see it today, only a gigantic cloud of dust and gas drifting silently in space. This cloud, known as the solar nebula, stretched across billions of kilometers. It was made of hydrogen, helium, and the remnants of older stars that had exploded long ago. Yes, every atom in your body was once inside an ancient star. At first, nothing seemed to happen. But gravity, the invisible sculptor of the universe, began pulling particles together. Slowly, clumps of matter started to form. They collided, merged, and grew heavier. In the center of this cloud, where gravity was strongest, pressure and heat kept rising until boom! The sun was born. The sun's birth was so violent that it blasted away much of the gas nearby, but in the outer rings of the solar disk, tiny pieces of rock and metal kept circling. These bits began to stick together, forming larger and larger bodies called planetesimals. Think of them as baby planets, crashing into each other in a cosmic demolition derby. Among these newborn worlds was one small, rocky sphere that would eventually become our home Earth. But in its early days, it was anything but welcoming. Temperatures on the surface reached thousands of degrees. Meteorites bombarded it from all directions. Each impact released enormous energy, melting rock into rivers of fire. The entire planet glowed red, covered in molten lava. If you could somehow travel back to that time, you wouldn't survive even for a second. The air was toxic, filled with carbon dioxide, sulfur, and steam. The sky glowed orange with volcanic ash. There was no blue, no green, no sound of waves, only thunderous explosions and lightning ripping through thick clouds of gas. But here's where the story gets even more dramatic. Around 4.47 billion years ago, Earth collided with another massive body, a Mars-sized planet scientists call Theia. The impact was catastrophic. Imagine an object as big as Mars hitting Earth at 16 kilometers per second. The collision melted both planets. A huge amount of rock and vapor was ejected into space, forming a glowing ring of debris around the Earth. Over time, that debris began to clump together, forming a new celestial companion, the Moon. Yes, our Moon was literally born from the wreckage of that apocalyptic crash. Without that impact, Earth might not have the stable tilt and tides that make life possible today. It's incredible to think that destruction gave birth to beauty, chaos created balance. As the molten Earth slowly began to cool, heavy metals like iron and nickel sank toward the center, forming the core, while lighter materials floated upward to form the mantle and crust. This process, called differentiation, shaped the layers of our planet. The core's formation was crucial. Its movement would later create Earth's magnetic field, a shield that protects us from deadly solar radiation. But for now, Earth was still a furnace. Volcanoes erupted constantly, spewing gases into the atmosphere: carbon dioxide, nitrogen, water vapor, and methane. The heat from inside the planet met the cold vacuum of space, and something miraculous began to happen. The steam from those eruptions condensed, forming clouds. Then, for the first time in Earth's history, rain fell. Not a gentle drizzle, but storms that lasted millions of years. Torrents of water poured down, cooling the surface further and filling the lowlands to form the first oceans. Lightning flashed across the sky, volcanic ash darkened the air, and the sound of falling rain echoed on rock for the first time. Can you imagine that moment? The first drop of rain hitting the hot, rocky surface of the newborn Earth, sizzling into steam, again and again, until the planet's fiery skin slowly transformed into crust. Scientists believe this relentless rain continued for thousands of years, shaping the world's first oceans. These weren't the clear blue waters we see today. They were murky, acidic, and boiling hot. But they were the foundation, the cradle where life would one day awaken. Yet, at this stage, Earth's surface was still unstable. Asteroids continued to bombard the planet, bringing with them not just destruction, but also ingredients for life: carbon, nitrogen, and perhaps even water. Some of the water in your body today might have come from those cosmic visitors, frozen rocks that traveled millions of kilometers through space. By this point, Earth had cooled enough for a thin crust to form. Volcanoes built new mountains. Massive lava flows solidified into continents. The once molten ball of rock was now hardening, but inside, the core was still churning like a fiery heart, keeping the planet alive. As time passed, gases from the atmosphere began to change. Carbon dioxide levels dropped as it dissolved into oceans, while nitrogen and traces of other gases remained. Slowly, the sky began to clear. Sunlight started reaching the surface. For the first time, the sun, that same star that gave birth to Earth, illuminated its child. It was still a hostile world, but the foundation for life had been laid. Billions of years later, we would look back at this period and call it the Hadean Aeon, from Hades, the ancient god of the underworld, because the early Earth truly was a hellish world. But even in hell, the seeds of heaven were being planted. Think about it, if that giant collision with Theia hadn't happened, Earth might not have a moon to stabilize its rotation. Without stability, seasons would have gone wild, climates unpredictable, and life might never have evolved. Every violent event, every explosion, every asteroid impact was secretly setting the stage for something extraordinary. The story of our planet is a reminder that sometimes, chaos is not the enemy of creation, it's the very reason creation exists. Right now, you and I are part of a 4.5-billion-year-old chain of cosmic accidents, each one necessary for life to appear exactly as it did. And this fiery chapter is just the beginning. Because the question remains, how did a world born in flames turn into a planet of oceans, mountains, and life? That's where the real mystery begins, the transformation from fire to water, from chaos to calm. But before we dive into that part of the journey, take a second to think about this: everything you see around you, every river, tree, and living thing, was once part of that violent, molten chaos. Isn't it fascinating that the same fire that could destroy, also created? Keep watching, because in the next part, we'll discover how this once boiling planet cooled down, how oceans shaped continents, and how the first spark of life might have flickered into existence. The Earth had finally cooled enough to wear a fragile crust, but beneath its surface, fire still roared. Magma flowed like blood through unseen veins, feeding volcanoes that tore open the young planet's skin. Each eruption released clouds of steam, carbon dioxide, and ammonia. What had once been a deadly, choking haze was slowly becoming the planet's first atmosphere, a shield that would one day protect everything living on it. The air was still unbreathable. It lacked oxygen entirely. But the balance of gases, the pressure, the chemistry, all were beginning to shift. The once blinding glow of a molten planet faded, replaced by a dim red sky where storms raged and lightning flashed. Slowly, continents formed like scabs over ancient wounds. And then came the endless rain. Imagine torrents falling for millions of years, drop after drop, cooling the crust, filling basins, carving valleys. Steam rose from the hot rock until the air thickened with clouds. As the planet exhaled, it began to weep. Those tears became oceans. These first oceans were not blue and calm. They were dark, acidic, and boiling, filled with minerals from volcanic vents. Yet within that hostile brew, something extraordinary was brewing. When lightning struck the atmosphere, it split molecules apart. Energy from those strikes, combined with gases like methane and ammonia, created new compounds, amino acids, the building blocks of life. Deep under the ocean, volcanic vents known as hydrothermal chimneys spewed minerals and heat. In those vents, chemical reactions formed tiny bubbles that trapped in concentrated molecules. It was like a natural laboratory. Each bubble tried a different chemical combination until, one day, a miracle occurred: molecules that could copy themselves. The first self-replicating structures, the ancestors of DNA, had begun their slow march toward life. But let's step back for a moment. At this point, the Earth was still undergoing violent transformations. The crust cracked and shifted under immense pressure. Asteroids occasionally struck the surface, shaking oceans and spewing debris into the sky. Yet each impact also delivered new materials: water, carbon, even simple organic compounds from the depths of space. So if you're wondering, where did life really come from? Was it born here or delivered from the stars? The answer might be both. Perhaps Earth was ready, but the universe gave it a helping hand. The newborn planet was still learning to breathe. With every volcanic eruption, carbon dioxide filled the air, keeping the planet warm. Without it, Earth might have frozen under the faint young sun, which shone only 70% as bright as it does today. Ironically, what we now call a greenhouse gas was once a guardian, the blanket that kept early Earth from turning into an icy wasteland. Over millions of years, the balance continued to shift. The oceans grew deeper, covering vast areas. Land masses drifted and collided. Powerful currents churned the waters, mixing chemicals, spreading heat, and slowly stabilizing the climate. For the first time, Earth began to look somewhat familiar, blue oceans beneath a hazy orange sky. Now imagine being there. The sun, pale and distant, rises over a horizon of steaming water. Volcanoes tower from the sea, spitting fountains of lava into the air. Lightning flashes across endless clouds. Beneath the surface, unseen to any eye, chemistry is turning into biology. Here's a question for you to think about. What if the same cosmic accident that created Earth also made life itself possible? Had that collision with Theia not happened, there might have been no moon to control our tides, no stable rotation, no rhythmic rising and falling of oceans that mixed vital elements. Without those gentle lunar pulls, the chemistry of life might never have found its rhythm. So perhaps the greatest accident in history was also the first act of creation. In those early oceans, molecules were gathering into structures we call protocells, tiny membranes that trapped useful chemicals inside. They were not alive yet, but they were close. Some could store information. Some could harness chemical energy. And slowly, they began to compete, multiply, and evolve. The clock of evolution had started ticking. Meanwhile, Earth's surface continued to cool. The crust thickened, the first continents grew larger. Rocks absorbed carbon dioxide, locking it away and slowly clearing the atmosphere. The skies turned from orange to gray. Rain became gentler. The planet that once glowed red was now painted in shades of blue and brown. But danger still lurked in the heavens. The solar system was not yet peaceful. Between 4.1 and 3.8 billion years ago, Earth was bombarded by massive asteroids in what scientists call the Late Heavy Bombardment. Each impact could vaporize oceans and blanket the sky in dust. And yet, Earth survived every one. Like a warrior beaten and scarred, it refused to die. Some scientists even believe these impacts may have helped mix organic compounds deeper into the oceans, fueling the rise of primitive life. Every blow that could have ended the planet instead strengthened it. By the end of this violent era, something remarkable had changed. The Earth's crust was thick enough to support large landmasses. The atmosphere, though still toxic to humans, had calmed. The oceans, once boiling, were now merely warm. And hidden deep within them, microscopic lifeforms were beginning to stir. Tiny single-celled organisms, the first prokaryotes, appeared somewhere around 3.8 billion years ago. They were simple, fragile, and yet unstoppable. These were the first living things on Earth, ancestors of every plant, animal, and human that would ever exist. They lived near hydrothermal vents, feeding on minerals and chemical reactions rather than sunlight. Over time, they evolved new ways to survive. Some learned to use sunlight photosynthesis, a process that would soon transform the entire planet. But that's a story for another part of our journey. At this stage, what matters most is this: against impossible odds, life had found a way. Out of heat, pressure, and chaos, something began to breathe not air, but energy. Imagine how silent those first breaths must have been. No birds, no wind through trees, no sound at all, only the bubbling of deep-sea vents and the whispers of chemical life. From a scientific point of view, this was chemistry turning into biology. But from a human perspective, it was nothing less than the universe awakening to its own existence. For the first time, matter began to sense, to respond, to change purposefully. And think about it, all of this happened long before dinosaurs, before continents as we know them, before oxygen even filled the air. Our planet was already writing the first chapter of a story that would one day include us. So the fiery world of lava had become a world of water. The violent chaos had cooled into calm seas. And within those seas, the first spark of life flickered. But Earth's transformation was far from over. Those tiny living cells were about to change everything, even the air itself. Because in the next chapter of this story, life would learn to reshape the planet that created it, turning a toxic world into one capable of supporting complex creatures. From molten rock to microbes, from chaos to chemistry, the Earth's journey had just begun. Life had begun as something invisible, microscopic, fragile, and hidden deep under the oceans. Yet these tiny organisms were about to perform the greatest transformation in planetary history. The fiery Earth had cooled, the oceans had formed, and now life itself would begin to change the sky. At first, the world remained unrecognizable. Volcanoes still erupted, continents drifted restlessly, and the air was thick with carbon dioxide and methane. But in the shadows of the seas, certain microbes discovered a new trick, the ability to use sunlight. They were the earliest cyanobacteria, sometimes called blue-green algae, and they learned to capture light energy and turn it into food through a process called photosynthesis. This single innovation would rewrite the destiny of the entire planet. When cyanobacteria absorbed carbon dioxide and water, they released a byproduct no one had ever seen before: oxygen. At first, that oxygen didn't accumulate. It reacted with iron dissolved in the oceans, forming rust-colored minerals that sank to the seafloor. Over millions of years, those minerals created the vast iron deposits that humans would later mine for steel. But eventually, the oceans couldn't absorb any more. The extra oxygen began to leak into the atmosphere, slowly, silently, molecule by molecule. For early life, oxygen was poison. It destroyed the chemistry that had allowed those first microbes to survive. Many species went extinct. Yet evolution had already learned its favorite lesson: adapt or die. New organisms evolved that could tolerate oxygen and even use it. Around 2.4 billion years ago, this shift became dramatic. Oxygen levels in the air rose sharply in what scientists call the Great Oxygenation Event. The sky, once orange and hazy with methane, turned a clear blue for the first time. The ozone layer formed, shielding the surface from deadly ultraviolet radiation. With that, Earth became a truly living planet. But change always has consequences. As methane, a powerful greenhouse gas, disappeared, global temperatures plummeted. The world that had once burned became frozen. Ice spread from the poles toward the equator in one of the planet's earliest Snowball Earth episodes. The oceans may have been covered in ice for millions of years. It seems ironic: life created oxygen, oxygen changed the climate, and the climate almost wiped life out again. Yet the survivors adapted once more. Beneath the frozen surface, volcanic heat and chemical vents kept small pockets of liquid water alive. In those hidden sanctuaries, evolution continued its quiet work. Over time, volcanic eruptions released more carbon dioxide, warming the planet again. The ice melted, oceans thawed, and the world reawakened. But it wasn't the same Earth anymore. Oxygen had transformed not only the air but also the possibilities of life itself. With oxygen available, cells could extract far more energy from their food. Some microbes merged with others, forming more complex cells called eukaryotes, the ancestors of all plants and animals. Inside them, tiny powerhouses known as mitochondria evolved, allowing cells to grow larger and more efficient. It's hard to imagine how monumental this step was. For nearly 2 billion years, life had remained microscopic, single-celled, invisible to the naked eye. Now, the door to complexity had opened. The oceans turned teeming and alive with new forms. Simple colonies became multicellular organisms. They began to specialize: one cell handling movement, another digestion, another sensing light. Cooperation had arrived. Meanwhile, Earth itself kept changing. The planet's crust was restless, broken into massive slabs we now call tectonic plates. These plates floated on molten rock, drifting slowly, colliding, tearing apart. When they collided, mountains rose. When they split, new oceans formed. This slow dance of continents reshaped the face of the planet over and over again. But it also played a deeper role: it recycled carbon dioxide between rocks, oceans, and the atmosphere, keeping Earth's climate stable enough for life to thrive. Around 800 million years ago, the continents drifted toward one another again, forming a giant supercontinent called Rodinia. Massive volcanic eruptions poured carbon dioxide into the air, warming the climate, only to be followed by long ice ages that froze nearly everything. Earth had become a planet of extremes, fire and ice swapping dominance. During these harsh times, life evolved new ways to survive: spores, shells, and tough membranes. Every challenge forced innovation. Every disaster became an opportunity. What followed was one of the greatest explosions of life in history, the Cambrian explosion. Within a relatively short span of geological time, the oceans filled with strange, beautiful creatures, trilobites with armored shells, worm-like predators, soft corals waving in shallow seas. Evolution had gone into overdrive. But before we jump too far ahead, think about what this means. A planet that once glowed like molten metal was now covered in oceans, continents, and life so diverse it would take scientists centuries to catalog it all. Every part of this transformation, from volcanic ash to living coral, was guided by simple physical laws: gravity, chemistry, time. Yet from that simplicity came unimaginable complexity. When you breathe in now, the oxygen in your lungs exists because of those ancient cyanobacteria that changed the world billions of years ago. When you stand on a mountain, the rock beneath your feet is shaped by tectonic forces that have been moving since the planet's birth. You are, quite literally, standing on the echoes of creation. So, by this point in Earth's story, the stage was set. The planet had oxygen, oceans, continents, and a stable climate. Life had moved from chemistry to complexity. But something even more incredible was coming: the rise of animals, plants, and eventually, us. The universe had taken dust and fire and sculpted it into awareness. Before we continue that part of the journey, pause for a moment and imagine, if you could witness the timeline of Earth from its fiery birth until now, you'd see an endless cycle of destruction and renewal: meteor impacts followed by life's rebirth, ice ages thawed by volcanoes, extinction followed by evolution. Every ending was a new beginning. And that pattern, that unstoppable rhythm, is what makes our planet unique. It doesn't just survive chaos. It evolves through it. So, as we move into the final part of this story, we'll see how the Earth, already teeming with life, continued to change, how continents drifted to form the world we know today, and how humans eventually emerged as the latest chapter of this 4.5 billion year epic. The fire that once forged rock would one day burn in the minds of beings capable of asking, where did we come from? And so, from that mysterious chemical dance in Earth's ancient oceans, something incredible began to happen. Simple molecules, carbon, hydrogen, nitrogen, oxygen, started forming more complex chains. They bonded, broke apart, and reassembled, over and over, until one day, one of these chains learned how to copy itself. That tiny spark of replication was the moment life was born. No loud explosion, no miracle flash, just chemistry finding a way to persist. And from that moment, everything changed. That single, fragile process, the ability to replicate and evolve, transformed Earth forever. Imagine this: billions of years ago, beneath a dim orange sky filled with lightning and volcanic ash, microscopic life forms floated in the ocean. They had no brains, no eyes, no idea what they were, yet they were the beginning of all of us. Every tree, bird, human, and fish you've ever seen can trace its ancestry back to that ancient ocean, to that single spark that dared to live. But Earth didn't make life easy. Meteorites still bombarded the surface. The atmosphere was toxic. The sun's rays were harsh and deadly. Many early attempts at life probably failed, destroyed before they could replicate again. But evolution is persistent. Each failure left behind clues. Each success learned to adapt. Slowly, molecules developed protection, membranes, shells, and systems to store energy. Billions of years passed in this silent struggle. Life became more complex, first bacteria, then multicellular organisms. The oceans filled with microscopic diversity. Photosynthetic bacteria began releasing oxygen as waste and unknowingly created one of the biggest transformations in planetary history. The Great Oxygenation Event. At first, it was a disaster. Oxygen was toxic to most early organisms. It wiped out many ancient species. But for others, it was an opportunity. Oxygen allowed energy to be produced far more efficiently. It became the fuel for more complex life. The sky changed color, the air became breathable, and slowly, the planet began to look familiar. Earth's surface cooled further. Continents began to form and drift. Volcanoes continued to shake the land, building mountains and islands. The once orange sky turned blue. Clouds brought rain that carved rivers and valleys. The fiery world of lava had now turned into a planet of oceans, forests, and endless horizons. And somewhere in those vast oceans, new life continued to evolve. Fish, plants, reptiles, mammals, each one a new chapter in the book written by time itself. Until finally, humans appeared. We are the latest result of 4.5 billion years of cosmic accidents, fiery chaos, and delicate evolution. Every breath you take today is made of atoms that were once part of stars, volcanoes, oceans, and even the first living cell. Pause for a moment and think about that. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all were forged in the heart of ancient stars. We are literally made of stardust. The same cosmic material that burned in the sun, exploded in supernovas, and fell to Earth billions of years ago now flows inside you. Isn't that extraordinary? That from destruction came creation, and from chaos came consciousness? But here's a thought: if life on Earth was born from such precise and rare conditions, could the same process be happening somewhere else, right now, in another galaxy? Could another planet, orbiting a distant star, be forming its own oceans and its own version of life? The universe is unimaginably vast, filled with billions of galaxies and trillions of stars. Statistically, it's almost impossible that we're the only ones. Maybe somewhere out there, another Earth is just beginning its fiery story, its own molten ball waiting to cool, its own oceans waiting to rise, its own life waiting to breathe. And yet, even as we dream of other worlds, we must remember how precious ours is. This blue planet, born from fire, shaped by chaos, and nurtured by time, is our only home. Every forest, every river, every breath we take is the result of billions of years of fragile balance. We often forget that the same forces that created us can also destroy us. Climate change, pollution, and greed threaten the harmony Earth has achieved over eons. We are not separate from nature, we are its latest expression. The guardians of its story. The storytellers of its legacy. So the next time you look up at the night sky, remember this: the stars you see are not just distant suns. They are your ancestors. The fire that once burned in them burns quietly within you. You are a continuation of that cosmic story, a living witness of the universe trying to understand itself. And maybe, that's the real miracle of creation. That a ball of molten rock could cool into oceans and forests. That mindless molecules could grow into beings capable of love and thought. That the universe, in all its vastness, could give birth to something that looks back and asks, why are we here? This is the story of Earth. Born from fire. Shaped by time. Alive with wonder. And we, humans, are just its latest whisper in the endless echo of creation. If this journey through time amazed you, make sure to like this video, share it with your friends, and subscribe to World's Echoes, where we uncover the stories that reveal the hidden truths of our world and beyond. Because sometimes, the most extraordinary stories are the ones beneath our very feet. Thank you for watching, and remember, our planet's story is still being written, and every one of us is part of its next chapter.